Hello everyone, welcome back. You would have by now finished watching lectures up to week 5. Hopefully you have also completed the assignments and turned it in. If you have questions, please feel free to questions about the assignment problems or questions about the lectures or general questions that you would like to get clarifications for. Please reach out to us through the discussion forum or write an email to the instructor, one of the instructors. You can write an email to me. The purpose of this introductory video is to give you an overview of the content of weeks 6, 7 and 8. Week 4 and 5 was completely solid propellant rockets and solid propellant combustion, and week 6, 7, 8 deals with the following things. First is combustion in liquid propellant rockets. Second is some aspects involved in modeling of combustion processes with particular emphasis on combustion of liquid fuels, because the context of the subjects discussed in these 3 weeks is liquid propulsion systems. So particular emphasis is given on modeling liquid fuel combustion. Okay, basic ideas of turbulence and other things are also introduced, but mostly liquid fuel combustion. Week 8 deals with deals with combustion processes in scramjets. Okay, this is an air breathing propulsion system, which is a sought after propulsion system for hypersonic propulsion, hypersonic vehicles. Okay, and this is discussed in some detail in a 2-part lecture. And then you will also find summary lectures, 3 summary lectures, which sort of summarizes the entire content of the course. So one summary lecture on premix flames, one summary lecture on non-premix flames, another one on solid rocket propulsion, and some additional insights. These additional insights are essentially answers to the questions that the participants asked during the course of the lectures. Okay, so that is an overview. Let's look at what is there in week 6. First 2 lectures, there are 4 lectures in week 6. First 2 lectures deal with general processes in a liquid propellant rocket, which includes its basic design, propellant feed system, combustion chamber design, and so on. Then there is a discussion of aspects in combustion and liquid rockets, again general aspects of combustion and liquid rockets. Then comes an important lecture on instabilities in liquid rockets and gas turbine afterburners. This is a very serious problem that is faced by developers of propulsion systems, and this is the understanding of this phenomena is emerging. Its new insights are continuing to come, adding to the understanding of existing existing theories and models. Of course, unlike in solid rocket, longitudinal instability in solid rockets, which was discussed in week 4 and 5, there are no concrete answers that can be given, but general aspects are discussed, and a new way of looking at the phenomenon of instability in liquid rockets and gas turbine afterburners is presented. Hope you will find that interesting. Moving on to week 7. Week 7 more or less deals with modeling aspects. As it was brought out in one of the earlier lectures, the complexity in modeling of combustion and propulsion systems is primarily because of interaction of turbulence and flame, and to a lesser extent because of interaction of sprays and droplets with turbulence. Okay, and these are the principal aspects that are discussed in week 7. It starts with a bit of fundamentals of CFD, the modeling aspects involved in combustion. Then follows specifics of how combustion of liquid fuels or droplets of liquid fuels are handled in a modeling framework. Not very detailed, just the principal aspects to give you the necessary foundations so that you could go back and look at details and other emerging ideas in this field. These are the first two lectures. The third lecture is something that deals with interaction of turbulence on flames. Several basic ideas of turbulence and its interaction with flames are introduced. The hierarchical structure of a turbulent flow, starting from a large scale integral size eddy to the Kolmogorov scale eddy, is introduced first, and then using the ideas derived from that, we move on to the interaction of turbulence with flames. There is only one key idea that is discussed in some detail, which is called the flamelet approximation. This is a very simple thing. The flamelet approximation is nothing but assuming that the flames are much thinner compared to the relevant length scales of turbulent flow. Okay. This allows for segregation or separating out modeling of turbulence from modeling of combustion. Okay. So, if the flames are much thinner than the relevant turbulent length scales, then the flames can be modeled as laminar flamelets, for which solutions can be computed a priori, converted into a lookup table, and this significantly simplifies the computation of processes in actual propulsion systems, and this key idea is discussed at some length in the third lecture. Okay. And this approximation is a very good approximation, or a very good first approximation for almost all propulsion systems. Okay. And then there is week 8. Week 8 exclusively, the first two lectures deals with scramjets, some very interesting aspects of constraints that additional constraints that come into design of a scramjet. Scramjet is, if you think about it, it's essentially a duct. Unlike any other propulsion system which has a turbine, a compressor, a combustion chamber, and so on, complicated rotating parts, scramjets are nothing but a duct in which enthalpy is added to a high speed, high temperature fluid stream, resulting in the production of thrust. And of course, this is possible, or it is possible for a scramjet to generate positive thrust only at high Mach numbers, supersonic Mach numbers. And this brings about a lot of constraints which are not usually encountered in other propulsion systems, and makes up for a very challenging and interesting design. Okay. And with that, the course is complete. There are 4 more lectures. 3 of those lectures are, as I mentioned earlier, are summaries. Hopefully, this is something that you can come back to occasionally whenever you are having doubts, or how different things that are discussed in this course are connected. If you have questions of that kind, you could come back to one of these summary lectures after you have completed the course, or perhaps even when you are doing the course, when you are going through the lectures, if you are feeling a bit lost, you are not able to see what the connection between two different topics that are discussed, you can always come back to one of these summary lectures to get an idea of what's going on. Okay. So the summary lectures are split into 3 parts, one on premix flames, one on non-premix flames, and one on solid rocket propulsion. And then there is an additional lecture which deals with combustion in what is called a moderate to intense low oxygen dilution combustion idea. Again, as I mentioned earlier, this is something that was done to clarify some questions that were raised by the participants of the course, and this has been added as a part of this course with the hope that it will answer some of your questions also. Okay. This brings me to the end of the introduction to the week. Hope you will enjoy the lectures, and do reach out to us if you have questions, clarifications, or if you have anything at all. Okay. Thank you very much. Good luck.